Thank you everybody for attending this SpectraCal webinar. Today we'll be talking about video calibration and introduction to the subject. We'll be covering a number of topics today. Among those, we'll be talking about the objectives of video calibration, what it is that we're trying to accomplish. We'll be talking about the different levels of picture quality improvement that are possible with different levels of calibration. We'll be talking about the video calibration process, overviewing that. We'll be talking about the calibration software that we use for calibrating video displays. And we'll go into the topic of light and color measurement, touching on how the human eye sees light and color and then how we measure that. We'll be talking about calibration hardware that is available for assisting with calibration, including color meters and test pattern sources. Along the way, we'll be doing demonstrations of the different facets of calibration, different steps along the way. At the end of the session today, we'll be talking just a little bit about selling calibrations to your clients. And we'll talk about additional training opportunities that are available for you for training and calibration. During the webinar today, rather than turning on the chat facility within GoToMeeting, we have decided to implement an email support system. The email that you see on your screen, webinarsupport@spectracal.com, is available during and after this webinar. Also, you can call either one of the two phone numbers that are listed here. I will be distributing a copy of this presentation that we're covering today to all attendees after the webinar, and so this information will continue to be available to you. What is calibration? Well, that is comparing and correcting the output of a device to a known standard. It allows us to balance science, knowledge, and our experience to most accurately reproduce the original artistic intent in our given viewing environment. Why might you think aren't monitors and TVs calibrated properly at the factory? And how are they adjusted? Well, many years ago, manufacturers learned through research that maximum perceived brightness and color sells more TVs. It allows them to create a unique look for their particular brand of TV, and thus the manufacturers provide a maximum adjustment of backlight and contrast oftentimes. They will increase the color saturation controls higher than an accurate setting. They will set the background color of the display to be more blue than what is the standard in order to make the display have a higher perceived brightness level, since the human eye sees blue as being brighter. And then in order to help to minimize the resulting picture inaccuracies from some of these misadjustments, they add in other enhancement features. In talking about the levels of picture quality improvement, there are three main levels that we'll be talking about today. First of all, picture menu adjustments. This is the first and potentially the most important. We need to establish a correct viewing mode. We need to set the color temp of the display to be close to our desired color temperature. So we're going to be talking about levels of picture quality improvement. The picture menu adjustments, first of all, including the viewing mode, the color temperature, setting the color of white on the screen to be close to our desired color temperature, picture size, including aspect ratio, sharpness or edge enhancement, and then also the standard adjustments for brightness and contrast and color and tint. These form the basis of our calibration and are potentially the most important adjustments we make. The next level of adjustment then would be the white balance adjustments, which would cause the color of the gray or white portions of the screen to be the desired color of white or gray at all different luminance levels. This is also known as grayscale tracking. And then from an advanced perspective, in some cases we may also make color gamut adjustments, CMS or color management system as they are sometimes known. These adjustments will be used to set the color of the primary and secondary colors on the display to target values. But this is an advanced topic that we will not be going into in depth today. The calibration process then consists of a couple of major steps. First of all, we typically will want to document the initial performance of the display as we found it in order for documentation purposes, for reporting or for recording for our own sake. We'll then preset the picture menu controls that I just spoke of, including brightness and contrast and others. This is important because before we perform the next step, the adjust white balance step, these controls need to be very close to their final adjustment in order to get an accurate white balance adjustment. Then we will actually perform the white balance adjustment of setting the white balance of the display so that it tracks well across the luminance range. Once we've done that, we'll need to go back and readjust some of the picture menu controls because there will be an interaction effect between the white balance and picture menu adjustments. And then finally, we'll document the final performance of the display by capturing its performance to document its as-left condition. In just a second then, we'll go through the start of an introduction to the CalMAN software. I'll show you the user interface for the CalMAN software. We'll talk about the workflows that are available for guiding us through the calibration process, talk a bit about documentation reports. We'll go through hardware setup, and we'll then perform the pre-calibration capture step. So let's switch over to that software. So in the middle of the screen where you see the SpectraCal logo is where the main activity will normally take place during our calibration. This is where the measurements will be seen, the instructions will be given for helping you to step to step as we go through the workflow. That workflow listing is shown in the upper left corner of the software screen, and this is the Pro Monitor workflow. Each one of these listings is a different calibration step that helps us to accomplish one more item in our checklist for calibration, for setting brightness, for instance, or contrast, and we'll go through those after a bit. There are a number of workflows that are available with the CalMAN software. I am going to click the Load Workflow button, and that brings up the listing of different workflows that are available for different specific purposes, whether that be for calibrating a specific piece of hardware, different displays, or for calibrating for CMS, for instance, as I mentioned, when we're going to be doing color gamut adjustments. And so we can select different ones of those workflows depending upon what our needs are at a particular time. On the right side of the display are the settings selections where we are able to access meter settings, source settings, and display control. First of all, let's take a look at the meter settings. This is where we would make connections to a particular color meter. The color meter I'm using here today happens to be a Klein K10 meter. Let me disconnect that and show you the process that we would normally go through in order to connect to a particular meter. So once we have a meter connected to a port on our computer, we would click the search button. Search screen comes up. In the case of these special case instruments, we need a indication that one of those is connected, in this case a Klein instrument. If the meter you're working with is not on that list, you would then simply go ahead and click the search button. Wait for a minute as the computer searches its interface ports to see which meters are connected there. In this case, it knows that it's searching for the Klein because I told it that. And after just a minute, then it will have found that meter. It will connect to it, and that meter will then be listed in the meter drop-down box. Some basic information on the meter will be listed to let us know that in fact it has connected to the desired meter. Likewise, we're going to be connecting to a test pattern source. In this case, today I'm working with the AV Foundry Video Forge generator. Let me disconnect that and just show you the process that we would go through for connecting to a particular source. We would normally, from the list of available test pattern sources, we would select whichever hardware item it is that we're using for test patterns. In this case, we are, as I said, using the Video Forge generator. So I would select that from the list and then simply click the Connect button. And again, the software would go out to the ports on the computer, identify that connection, and set that up properly. Also, if we are working with a display which is supported within CalMAN, a Panasonic, a Runco, a Sharp display, for instance, or one of the processors, we would select those in order to have automated control of that particular device. And that's beyond, again, what we're going to be working with today, so we will not be setting up an automated display. So as we work through the workflow then, the session setup would give us a chance to enter customer information. And I'm going to skip a step or two here and go on down to the pre-cal capture step, one of the main next items that we're going to be accomplishing. Here we would have the opportunity to enter information about the display that we are calibrating, both its identification information and its initial settings if we wish. We can then click the meter read button, and let me show you the webcam as that's happening. Resetting the exposure setting there just a bit. There we go. And so you see on the webcam that the test pattern generator is generating different fields of shades of gray in order to characterize the display's performance across the luminance range. And then in just a moment, it will switch through the primary and secondary colors in order to characterize its color gamut performance. So it's gone through the primary colors and now through secondary and finishing up on yellow. Okay, in the upper right section of the software, we see the RGB balance graph that indicates the balance of red, green, and blue. If those three colors were balanced out properly to give us the desired color of white across the luminance range, we would see that red, green, and blue would all be at the midpoint on the graph here at the 100 line across the entire graph. We see, however, that that's not the case, that blue is at an amplitude much, much higher than red or green. In fact, that is typical of televisions out of the box because, as I indicated earlier, manufacturers oftentimes want them to be quite blue to appear brighter to the human eye. So with that, let's step back to the presentation. Excuse me, there we go, and turn off the webcam for a moment. So we've talked just a moment about the calibration software that's available to us. We'll come back to that in just a minute. Right now, let's kind of outline what the what the connections are that we would use for the different pieces of hardware that we have set up. And this is very typical that we would have a laptop running the calibration software. A meter connected to the laptop would be pointed at the center of the screen in order to make measurements there. A generator would be generating test patterns to the display with a HDMI connection to the display, for instance, and that would have a control cable coming from the computer in order to control it, in order to command it to produce the desired test patterns at the appropriate times. Again, if you've come in late to the session today, if you have questions, please direct them to webinar support at spectracal.com. We will be handling those questions on a live basis during the webinar and then afterwards as well. So once we have the initial performance of the display captured for documentation purposes, one of the first steps that we want to accomplish on the display is to set up an appropriate viewing mode. This provides the best starting point for our calibration. We want to select a picture viewing mode that both enables the adjustment of brightness and contrast controls. In some cases, some displays do not allow that adjustment in some of their modes, and so we want to be sure that we select one that does allow that adjustment. And we also want to select a viewing mode that sets the color of white fairly close to our white reference target. So let me turn the webcam back on, and let me bring up the menu on the display. And so here's the list of the available picture viewing modes in this particular, this is an LG display. We see that Vivid is the default selection. In fact, this television is reset to its out-of-the-box condition, and so this is the way that we would normally have seen the display when we first unpacked it. Also, there are a number of other modes that are available, and as I switch through those, you can see that the luminance level on the display is changing. In fact, I need to reset my exposure on my webcam in order to best handle that. In fact, on this display, we come down to a couple of expert modes, which we'll find are the ones that give us the full range of adjustment that we want, including our white balance adjustments. And so those are the modes that we're going to be operating in today. One of the next things we're going to be wanting to select after we've selected an appropriate viewing mode, which is probably a movie or a cinema mode, or in this case the expert mode, is to set up our picture size or pixel mapping. We want to be sure that our picture is not overscanned on HD signals, because if it does that, we know that the display is going to be reduced in resolution. And so let me switch over to a multi-burst test pattern. And coming into the display's picture adjustments, for the aspect ratio on the display, there are a number of settings. 16:9, first of all, is the default setting. And you can see in the upper right-hand section of the screen right now, up in this area. This is the area where on the test pattern we have the fine resolution portion of the test pattern, 1 pixel on, 1 pixel off, white, black, white, black, white, black stripes. But there shouldn't be the banding which is occurring here currently, the jail bar type look. However, that's what we get when the display is slightly overscanned, as many displays are in their default state. And so we're looking for a picture size condition that eliminates that banding. And Just Scan here is one that does that. And now we have a very uniform look throughout this area. We do not have that jail bar banding effect. Instead, we do have, when viewed up close, a very clean 1 pixel on, 1 pixel off look, which means that we have full resolution available now from the display, which is our desired intent here. Stepping back then. One of the other items that we want to set up on the display is the sharpness or edge enhancement adjustments. When we're viewing HD signals, we don't want edge enhancement producing edge artifacts. And so we're going to be wanting to set any edge enhancement or sharpness adjustment to as minimal setting as possible while still maintaining full resolution. And so on the webcam, you can see in the bottom part of the picture here, we have thin black lines on a on a gray background. Let me go to the sharpness adjustment. And as I increase that adjustment from that default setting of 50, you'll be able to see that there is a heavy amount of white haloing effect around those thin black lines. That's something we don't wish to have happen in the picture. In this expert mode, it appears that we have the sharpness actually set at a very good setting. At a midpoint, it has just minimized the haloing effect. As I came down from maximum down to 50, that haloing effect is minimized. As I go lower than that, I don't have any further reduction of that haloing effect, but I can see in the rest of the picture that it starts to soften out, and so I don't want to do that. So it looks like in this particular case, the default setting of 50 was appropriate. In other displays, you need to judge that on a case-by-case basis. Normally, you would adjust the sharpness control to a higher than normal setting in order to view the effects of the haloing of the edge enhancement, and then set that to minimize the edge enhancement without softening the fine resolution in the picture. Also then, we want to go into the noise reduction settings in the display and set those appropriately for the type of signal that we'll be feeding to the particular input that we are calibrating. When we are calibrating an input that is going to have a very high quality signal, such as from a Blu-ray player, we would want to set our noise reduction settings to a very minimum setting in order to minimize the effects on the picture. We do, however, when we have an SD signal coming in, so if we were calibrating an input that normally gets a signal from a set-top box, for instance, or a satellite or a cable set-top box, we would want to set the noise reduction to a little bit higher setting in order to minimize some of the noise artifacts from those compressed video signals. Also, we want to continue looking through the menu for other specialty features, as we refer to them, other items that may affect the picture in ways that we don't want that to be affected. For instance, here in the extended menu, we see a dynamic contrast setting, which is defaulted off here, and in the expert menu, that's expected. That is a desired setting for our calibration. If we were calibrating another mode and we found that dynamic contrast were turned on, we would want to switch that off. Anything else also that is a dynamic or an automatic type setting where the display is going to automatically try to figure out its own settings. We want to disable those functions so that our calibration adjustments can have the desired effect without the display overriding that. Our next major setting then is black level. We're going to be adjusting the brightness control to make the black picture content as dark as possible without losing the darkest gray picture content. Let's switch over to the software again, and let's take a look here. In the display preset section, we see that we have instructions that cover just the things that I've been talking about up until now. In the viewing mode section of the workflow, we get instructions here for selecting an appropriate picture viewing mode and for possibly selecting an appropriate color space. In the next step, we have the additional settings that I was just speaking to. for setting picture size, sharpness, noise reduction, and those specialty functions. The instructions are here to help us to appropriately set the menu settings for each of those different types of adjustments. So coming then into the brightness adjustment, step back for just a moment. Again, we want to adjust the brightness control to make the black picture content as dark as possible without losing the darkest gray picture content. And so over on the CalMAN software, what we're going to do is to go over to the Test Pattern Select button, which selects a brightness test pattern. I'm going to drop the menu here on the television so that you can see that. And I'm going to need to reset the brightness setting on my webcam so that you can see that. Okay, so when I go to the brightness adjustment now in the television, I'm going to affect the black level on the display. On the test pattern that we have here, we have different blocks at different signal levels, from black up through 23 level. In video, 16 and below are the black levels. 16 is black level. Anything below 16 is spoken of as blacker than black. You can see, I hope, in the webcam, and let me see if I can reset my exposure just slightly so that you can see that a little better. You can make out let's see here. Okay, my webcam seems to have locked up. Sorry for that. Give me just a moment. Let me see if I can remedy that situation. Okay, I'm going to, let me see here. Excuse me, folks, but I'm seeing whether I can remedy that webcam. I think possibly I can here. If you give me a second. There we go. Okay. And I'll reset the settings on that in order to optimize it for your viewing. There we go. Apologize for the delay. So now, as we were setting the black level of the display, we'll do that with the brightness control. And I have set that abnormally high. Let me go back and grab that control. Normally we would want all of the blocks at 16 and below to be black, with the 17 block just barely visible. So let me set the brightness control back down to a appropriate setting. I will set that down to where 16 is dark, and from my position here I can just barely make out 17 at about 57 on the setting. And so that would be an appropriate setting for the brightness control on this particular display. Now that will change with the lighting environment that you're viewing the display in, and so you want to be sure that you are setting this control while you have the typical lighting in the viewing environment. And let's switch back then to our presentation for a second. Here are some typical test patterns. We see the one that's closest to the one that I'm showing down here in the lower left with the different blocks at each of the individual levels from 0 on up to approximately 20 or so. Other test pattern generators will generate slightly different test patterns. A common element that's common to all of them, however, is the fact that they will typically have a black section of the pattern, a blacker than black, and a slightly lighter than black. That's oftentimes what's known as pluged bars. The way that we would set those with those other test patterns is that we would adjust the brightness control to the point abnormally high, to the point where we would be able to see a blacker than black bar differentiated from the black background, which is the 16 level. Then we would reduce the brightness control in order to just lose sight of that blacker than black bar, while still being able to see the bar which is just slightly brighter than the black level. And so any one of these patterns is usable in that same method. It's just a matter of knowing how to use the pattern. Next in our adjustment is the peak white level. We'll set that with the contrast control. The idea here is that we want to give ourselves as much dynamic range in the picture processing circuits as possible. We want to make the peak white picture content as bright as possible without clipping or compressing that bright white picture content. And so, for instance, if we had an outdoor scene with a bunch of fluffy clouds in the sky, if we push the contrast control excessively high, what we would find would happen would be that the parts of the clouds that were not quite at the brightest white would also be pushed to that highest white level, and we would start to have some clipping, as it's called, or white compression, where it would look like the different levels of bright gray would all blend together. So we would lose some of that bright gray detail, and that's something we don't want to have happen. So we want to use an appropriate test pattern to be able to set the brightness control, the contrast control as bright as we can, but without losing that bright gray detail. And so let me switch over to the CalMAN software again. We go to the contrast step where it gives us that information, that instructions in this particular step. We'll select the test pattern select button, and now with my webcam that overexposes me greatly, so I'll set that back down and set that so that you can see the different levels in that brightness test pattern. So here in this test pattern we have the levels from 232 up to 255 down at the bottom right. And right now, as it probably looks on your webcam, that you don't see any of the levels along the bottom of the pattern. In fact, that's just the way it is. Those levels are, in fact, blended together, and so we know that the contrast is probably at too high a setting. And so let's access that contrast control and adjust that downward somewhat. And as I do that, you can see that immediately some of those levels pop into the bottom of the screen. Again, let me push that back up again where it was, and as I do that, you'll see that those levels at the bottom of the screen are starting to disappear again. Bringing that level back down, I want to take the contrast control low enough, and I'm going to take it excessively low right now, and then bring it back up. As I bring it up, I'm looking for two things to potentially happen. I'm looking for some of those bars to start to blend into the white background, which I'd rather not to have happen, or I'm looking for some overall color tone shift in the pattern, which I also don't want to have happen, which would indicate that one individual color is being slightly compressed. And so as I go higher and higher with the control, I find that about here I start to lose. So about 80, I started to lose some of the bars on the bottom. So I know for sure that I don't want to go any higher than that. And as I go lower than that, I don't see any significant tonal shift in the picture. And so I'm going to leave that at about 80, which will give me a maximum dynamic range in the signal processing circuits. And we would do the same thing with any one of the other test patterns from other test pattern sources, where again the common theme there is that we have a bright white, a white portion of the test pattern with other bright gray sections on that, and we want to set the contrast control as high as we can without losing that bright gray detail, not blending it into the background. Next, we want to set the overall luminance level of the display. We've set the contrast control for maximum dynamic range. That did have an effect on luminance level, but we normally won't use the contrast control to set that overall luminance level. We would instead use the display's backlight control, or sometimes on a plasma display that might be known as cell light. We want to use that to set our overall illumination level in order to be most appropriate for the level of illumination in our viewing environment. In a bright room, we find that the luminance level we want is about 50 to 60 foot lamberts, whereas in a dark room it's down around 30 to 40 foot lamberts. And so we would select the particular level that we wish depending upon what the room illumination is. And then in the CalMAN software, in that next step, which is for setting that luminance, we're going to click the measurement button. That automatically puts up the correct test pattern on the display and starts making measurements. And here in the upper right section of the software, you see the luminance measurement that's being made. In this case, it's about 36 foot lamberts. If we decided that we would, depending upon the room illumination, we'd rather have more light output than that, we can govern that by our backlight control, which I'm accessing now. That is currently set at 30. I'm going to increase that. And you'll see that the measurement here in the upper right section of the screen has now gone up to 61 foot lamberts. And so depending upon what the illumination is in the room, we would set that to an appropriate level. And the measurement keeps updating for us. Okay, let's switch back to our presentation for a second for one more topic of discussion. And that concerns gamma. We've already set the ends of our luminance range, our black level and our peak white level, using the brightness and contrast adjustments. The rest of the picture levels, the mid-range levels, are affected by a control adjustment or a setting which is known as gamma. That affects each of those mid-range levels in comparison to the white level, basically. How do we make the selection? Well, we can do that by measurement, but what it'll affect is the overall light level or the contrast, so to speak, of those mid-tone levels. If the gamma is set too high, the midtones will be too dark. The picture will lose dark detail. If the gamma is too low, those mid-tone levels will be brighter than what they should be with respect to the rest of the picture. Normally we would set that for about a 2.2 gamma in order to duplicate the performance that the authoring editors set up in the editing suite that where they authored the program content. However, if our lighting environment is different than what it was in that authoring suite, we can readjust the gamma slightly differently in order to compensate for our room light. So in a bright room where we have much light competing with the picture content, we might want a little bit brighter set of midtones so we don't lose the shadow detail, for instance. And there we find in a bright room that about a 2.0 gamma works well. The dim room, which accurately reflects the original authoring environment, would use a standard gamma of 2.2. And for a dark room environment, where we are darker actually than the authoring environment, a little bit darker set of midtones would actually work well with a 2.4 gamma. So let's take a look in our software again at that gamma selection step. And what we're offered here is a measurement graph that allows us to plot the performance of the display with respect to gamma. And so when I click the measure button, the software is starting to select different luminance level measurement screens and making measurements from that. And the graph at the bottom of the software screen here is plotting the gamma performance. Now we have the target line set at 2.2, and that's selectable in the settings on the side of the software here, but we can see that the plot for the performance of this display right now is coming out fairly close to 2.2, rising just a little bit at the higher gray levels. We would go into the software if we wanted a different gamma performance than what we have found so far. We would simply select a different setting in the software, and then we can plot the performance of that. So in this case, gamma was set for medium. If I had decided that I would want a higher gamma, I can select that. I selected high. I'm going to exit out of that. And now back on my software screen, I'm going to set up a new measurement tab and make a fresh measurement of gamma with this new setting. And we'll see what the performance looks like here. If we had 4 or 5 different gamma selections in the display, we can set up different tabs to measure each one of them and then compare them to see which one we want to settle on for a final setting. And we see here that the gamma performance is now just a little bit higher gamma number, which is an opposite relationship to luminance, and so the luminance level is actually a little bit lower at those midpoints because of the higher gamma factor. So this was the performance with the high gamma setting, and back to the previous one, the performance with the medium gamma setting, and we can choose which one of those we want, again, depending upon the particular viewing environment that we're calibrating for. So we've covered the initial display presets for the viewing mode, brightness, contrast, luminance, gamma. Now we want to talk about calibrating color on the display. First of all, let's talk a little bit about the background or some theory about color. When we're talking about color on a video display, there are actually 2 aspects of color that we need to be aware of. First of all, there is the background color of the display, and then there's also the program color. I equate this to a watercolor painting, for instance, where we have the canvas that we're going to paint on, and then we have the watercolors themselves. And that's pretty much the way that the display is. The grays that we see in the picture when there's no color content present, that is our background canvas. So if we go to an entirely gray picture, for instance, let me switch back and just access a gradient grayscale. That gradient grayscale on the display is actually the background color of the display at different luminance levels. No color content. I see that our video camera, our webcam, is introducing a little bit of color shift there that really isn't as pronounced in the display. But This should be just neutral shades of gray then. That is the canvas upon which the rest of the program colors are painted. And let me turn off that webcam now for a while. The standard color for that color of white is something that we call D65, SMPTE standard D65. The black and white portion of the video signal actually contains the majority of picture information, and also it forms the basis upon which the program colors will be displayed. And so that background color is quite important. That background color is controlled entirely by the adjustments within the display itself, and that's what we'll be adjusting for white balance adjustments. Once that background color is proper, then the program colors, which are controlled by the input video signal, are displayed on top of the background color. They are translucent, so just like on a watercolor painting, the background canvas has a great impact upon the look of the individual colors. So if we had a different colored canvas, that would cause our painting, our watercolor painting, to have a different look to it. Likewise on color television. Excuse me. So we're going to be wanting to adjust those white balance adjustments in order to get the background color of the display at the desired color of white. Most video displays typically provide two sets of white balance adjustments, red, green, blue controls. One set of controls adjusts the color balance at a high light output, typically called gain controls, possibly drive. There are a few other names. There would be three controls, red, green, and blue, gain controls, for instance, which would be adjusted in order to get the desired color of white from the balance of those three colors. That would affect the color of the light output at approximately 50% luminance and above. Then there is also another set of controls in the display typically that affects the color balance at low light output, 50% luminance and below. These three controls would be adjusted for balance to give us the desired color of white when we have a low luminance test pattern. Typical names for those low light output controls would be offset or cutoff or bias, for instance. In order to adjust these white balance controls, however, we're going to need measurement tools because the human eye is just too adaptive to the color of white. As we change the color of white slightly, we can see that change. However, after we look at it for just a short period of time, it begins to look just neutral to us, and we can't tell the difference from one shade to the next as we're trying to make that adjustment. And so we'll need measurement tools to assist us in that. Let's talk a little bit more about the characteristics of light, though, before we talk about actually making those measurements with tools. Light, first of all, is actually electromagnetic energy, just like X-rays or microwaves or radio waves. Within a narrow range of wavelength, that electromagnetic energy, when it impinges upon the eye, it excites the retina and produces a visual sensation that we know as light. Each different wavelength of light energy, if seen by itself, would be perceived by the human eye and brain as a different fully saturated color. And so if a wavelength of light were present just in this section of the spectrum, for instance, the human eye brain would see that as a very fully saturated, a very vivid blue. Another wavelength here, for instance, would be seen as a very vivid orange. There are actually three human sight characteristics that define the way that we see light. There is hue, which is defined by the dominant wavelength of the color. You might think of that as the color of the color. The saturation of the particular color, which is the degree of purity from other light. And so a very highly saturated red, for instance, would be a vivid red. And as we desaturate that, we eventually go towards zero saturation, which is a neutral white color. The third human sight characteristic is brightness, which is the perceived light energy level. Now, in order to measure these three human sight characteristics, we would like to assign some measurement quantity, some metric to these. That's been quite easy with brightness. We simply measure that in a term that we call luminance, which is actually the radiated light energy level, either the foot-Lambert for the US unit of luminance or the candela per square meter. And so we're going to be simply measuring the light energy with a light sensor. For hue and saturation, however, the situation isn't quite as simple. We don't have a way of measuring hue by itself or of measuring saturation by itself, but the CIE back in the 1930s did come up with a combined method of chromaticity measurement, which is a combined hue and saturation measurement actually. They developed something that we now call the CIE chromaticity diagram, and from that we are able to specify different hues and saturations of color. And so the CIE chromaticity diagram is a diagram which gives the spectral colors, highly saturated colors, around the outside of this U-shaped diagram. And then as we move toward the center of that diagram, we progress to the white or less saturated colors. So as we pick any point on the diagram, as we go around the outside edge, we are different hues. And then as we move in or out toward the center, we are different saturation levels. And so as we pick a particular point on that graph, we are specifying a particular color with a certain amount of saturation and a certain hue. And then by referencing back to the X and Y values that are crossing that diagram, we can specify that particular point. An X value of 0.2, for instance, and a Y value of 0.6 would be a very green color. We also then have measurement tools which are able to measure a particular color of light and derive those same XY values so that we can use those for specification. A colorimeter is an instrument that is used to measure color stimulus in the same way that the human visual system perceives light. There are two basic types of colorimeters that we use in our industry to measure the color properties of emitted light. Those are spectroradiometers and tristimulus colorimeters. Big words, but two basic distinctions there. The spectroradiometer is a more expensive type device that is slower for measurement, but it is more accurate. It has poor sensitivity at low light levels, measures slowly at those low light levels, may take a long time to produce just a single measurement, but yet the spectroradiometers are inherently very accurate with all types of displays, and they may measure to high light levels. Tristimulus colorimeters, on the other hand, are of a different basic type of construction. They use just 3 sensors inside the colorimeter and get full light input to each of the sensors, which gives them some advantages that a tristimulus colorimeter is very sensitive at low light levels with very fast measurements. However, it's not quite as accurate as a spectroradiometer would tend to be, and so the tristimulus colorimeter has corrective calibration tables within it to correct it for different wavelength distributions of light energy. And so we'll need to have a different calibration table for each significantly different spectral power distribution. A little less convenient where we have to set up the calibration table. Excuse me. Also want to talk just a moment about test pattern generators, signal sources. We're going to want a reference test pattern source to play into our TV in order to calibrate the display. We then are also going to want reference content to play through our source devices, whether those be a disc player or an AV receiver or whatever. So for a reference test pattern generator to play directly into the display, there are two different generators that are currently available on the market. The Quantum Data 780, which is an HDMI handheld test instrument, gives us HDMI test pattern output plus some other troubleshooting capabilities. The AV Foundry Video Forge, also a 3D HDMI generator, doesn't give us quite the number of different types of outputs, only HDMI, but it does give us very good 3D test signal outputs. And so there's a kind of a trade-off in features between the two. When we're working back further in our signal source path, once we have calibrated the display, we'll be wanting to check players for proper operation, for instance, and so we would want a reference test disk to do that, and there are a number of those that are available, including these that are listed, the Spears and Munsell or Digital Video Essentials disk or the CalMAN Get Gray disk. These would be played in a DVD or Blu-ray player to provide reference test patterns to check the player operation. We'll talk about that a little bit later. So back then to our grayscale tracking adjustments for white balance. We're going to be wanting to calibrate the performance of the display so that it maintains a desired color of white across the entire luminance range. That's not going to be able to be perfectly maintained, however, and so we're going to have a little bit of error at different points in our performance process. And we've developed a way of measuring that error that I want to introduce, which is known as the delta E measurement. Delta E stands for amount of error. Without going into great detail about that, typical amounts of delta E for a out-of-the-box non-calibrated performance would be 10 up to 50 delta E, which means a certain amount of error from the color that we want it to be. Whereas for a calibrated display, we'd want the delta E typically to be 5 or less, indicating that the color of white or the color of gray that the display is producing is much closer to what its target state would be. And a delta E of 3 or less is effectively perfect. Normal humans in viewing two different colors of white, which are within a delta E of 3, would typically not notice that difference. So we're going to be going through a white balance calibration in just a moment. What we're going to be doing first is to identify the white balance controls on the display. We're going to be identifying two sets of controls, one for high brightness adjustment and one for low brightness adjustment of color. We're going to be actually adjusting those controls as we see the effect on the display and on our measurement software. And we're going to be adjusting the gain and drive controls in order to produce improved white balance performance at both high and low brightness. So let's switch over to the CalMAN software and switch to the next step, which is our adjust grayscale step. Let's first of all take a reading of the grayscale performance of the display, and I'll switch on the webcam so you can see that activity. Clicking the Read Series button on the CalMAN software, we start to generate test patterns and take measurements from those patterns. And in just a moment, you'll start seeing those measurements coming up, and you'll see that there is quite a difference between especially the blue performance level and the red and green, as we had seen earlier. You'll also notice in the delta E chart in the middle of the screen here, there is a green line marking a delta E level of 3, the yellow line marking 5, and then red is 10. And you'll see that the uncalibrated color of white at this 80% level, for instance, is beyond the 10 level. In fact, it's 13.8. And so what we're going to be wanting to do is to bring together the red, green, and blue levels across the entire luminance range so that the amount of error is down below an acceptable level. What we're going to do first is we're going to select a level of 80. That changes the test pattern level on the display, as you can see on the webcam. I'm going to start taking continuous measurements. And now I'm going to go access the white balance controls in the display for the high brightness settings for white balance. So opening up the picture menu, I'm going to go into the expert control menu and scroll down on that. And we get down to red, green, and blue contrast controls. Contrast controls are another name that LG has for the high brightness white balance controls. As we go down farther, you'll see that we have red, green, and blue brightness controls. Those are what other manufacturers might call offset controls, or cutoff controls. They are the low brightness color balance adjustments. So let's start first with the high brightness adjustments. And it's always advantageous to do that because the high brightness adjustments have most effect on the other rather than vice versa. And so it's going to go faster to start with these. Also, in adjusting the white balance adjustments, we'll typically try to leave the green adjustments as they were at default setting, adjusting only red and blue if possible. Unless we run out of range with those, forcing us to make a green adjustment, we would rather not change the green level because that will also affect the gamma performance of the display. So as soon as I select the red contrast adjustment and drop the menu out of the way, we see that both red and blue are high as compared to the green level in this single point RGB balance graph on the center right. And so I'm going to first adjust the red contrast control in order to bring the red level down to somewhat equal the green level. So as I make that adjustment, I'm adjusting down from the 0 default. I'm down at about a -20, and we'll see where that goes. And that was perhaps just a little bit too much. I'll bring it back up to a -19. Nope, actually -20 was closer. Okay, and so now I'm going to switch to the blue contrast adjustment, which is the high brightness control. And I'm also going to decrease it in order to balance blue with the default green level. Give it a second for that to stabilize, maybe another click or two. I'm now at a -25 on blue contrast. Another click or two perhaps. And I'm getting pretty close. Okay. And you'll also notice then on the delta E chart in the middle of the page that the amount of error is very low. In other words, the color of white that we're producing now is very close to the target color of white that we wish it to be, the D65 color of white that is set as our target. So now that I've balanced out the color of red, green, and blue at a high light level, I'm going to switch over to a low light level, selecting the 30% luminance level. And now in my controls, I'm going to scroll down far enough in order to get to the brightness controls, red, green, and blue brightness. And I'm first going to go to the blue brightness, and because blue is higher than green, I'm going to decrease the blue brightness control in order to balance it out. And we're getting just a little closer. Let's also go to red brightness and decrease it. Getting very close now. You can see that the delta E has gone very low, and it looks like I overshot my mark just a little bit. There we go. Also, you see on the expanded CIE diagram that our color of white is sitting right in the target box. And so now we've calibrated at 80% and at 30%. If the display is working well, once I resample the other points, we'll see whether or not it's capable of bringing those also down to an appropriate level. And so let's redo our series measurement to resample those other points. And we'll see whether we need to make a follow-up set of adjustments because of the interaction effect between the two controls. So at 40%, you see the delta E drop, 50%. Likewise, and we're hoping to see that happen across the entire range. If the display has linear grayscale performance, once we've made those two adjustments, once we've set its target properly at 80% and at 30%, the display should be capable of then spreading that adjustments, or those two adjustments, I should say, across the rest of the range. And it looks like it has done that fairly well. At 100%, we are just a little bit high. We're a little bit above the perfect level, but that's quite acceptable. And so we have a very good low error, very flat performance for our display over the viewing range, over the measurement range from our 10% level up to 100. So the next step then, let me step back to our presentation, is to readjust a number of the display adjustments that we had previously preset. These in particular, brightness, contrast, and luminance, are ones that may have been affected by the adjustments that we just made. And let me switch off the webcam for a moment. The brightness, contrast, and luminance may have been affected by the white balance adjustments that we just made, and so we're going to go back for a final setting of brightness, final setting of contrast, and final setting of luminance level. And then we're also going to adjust our color and tint. And so let's switch over to our software, and we'll see that in the workflow, after the grayscale adjustment page, that's just what we have. We have the final display adjustment steps, brightness, which is the same procedure as what we had followed earlier. Turning the webcam back on, you can see that there's a dark screen there. Let me set my exposure up on my webcam a little bit so you can see that a little bit better. Again, we previously had set that so that the 16 level was black and we were just barely able to see 17. Now it looks like, because of the white balance adjustments that we made, that has changed somewhat. So let me go back into the menu, reaccess the brightness control, and I'll reset that. Looks like I'm going to need to bring that back up just a couple of clicks in order to just barely be able to see 17 while 16 stays dark. Our next step then is to go to the contrast adjustment step. Let me reset the exposure on my webcam. And with that exposure setting, it's creating a bit of a color shift in the webcam for you that is not indicative of what we're seeing here on the screen. I see a very, very neutral screen where all the gray levels are very much the same color. The only thing I do see is that we are clipping some of these levels, so our contrast control may now be just a tad bit too high, and so I'm going to go back and double check that setting and see whether, oh yes. So as I drop a couple more steps, I bring back these high brightness, high gray bars that were previously blended into the white background. So as I go up, to 80 and 81, those drop away. And so I'm going to drop my contrast setting down to 78 in order to regain those higher levels without doing the white compression. Our next step then in the software is to recheck the luminance setting on the display. Again, by clicking the measure button, the software automatically commands the test pattern generator to put up the appropriate 100% white window, and we're making a luminance measurement. And if we had decided that we wanted 45-foot Lamberts, we could do that, for instance. Bring back the picture menu, access the backlight adjustment, and here we're going to simply fine-tune our backlight control for whatever light level we wish to have. If we wanted to have 45-foot Lamberts, for instance, we could easily do that. Next step then is for setting the color decoder adjustments, which include the color and tint controls. When I select the appropriate test pattern, I get a set of colors here which include blue and white, which are the two that I'm going to compare in order to properly set the color control. Those 75% blue and 75% white bars should look the same intensity when either viewed through a blue filter or when viewed together by turning on the blue-only mode that some displays have. This display does not include that capability. On some displays, they have a blue-only mode that allows you to see only the blue content out of the signal circuits, and we would be able to see whether those two levels are the same intensity. If they are not, we would then simply adjust the color control in the picture menu in order to equalize those intensities, or as viewing through a blue filter. And then looking at the cyan and magenta blocks that are laid adjacent to each other, we would view those two blocks in order to evaluate the setting of the tint control. If those two blocks do not look the same intensity through the blue filter or as seen in the blue-only mode, we would adjust the tint control in order to equalize them. That then concludes the adjustments for calibration, and a final step then would be simply to perform our final post-calibration capture. So let's do that now, and we'll see the improved performance that we have now. This then will also give us the data that we want to push into our report, for a report either for our own records if we're doing in-house calibration, or for client records in order to present to a client if we're doing calibration for an outside client. And as we had seen earlier, we do have good balanced performance across the luminance range, where red, green, and blue are tracking very close to each other. Then we also gain information about the color gamut on the CIE chart in the lower left. And when that completes, we'll step to the next step in our workflow here. And it has done so, so let me turn off the webcam and go to the next step, which is a set of instructions for us to help us to properly configure our source components. Now that we have our display calibrated, we want to make sure that our source components feeding signals into the television are giving us accurate signals, and so they aren't producing incorrect black levels, for instance, or incorrect color. And so by playing a reference test pattern disc in our players, or by properly evaluating movie or other content on our displays through set-top boxes, we can properly determine an appropriate setting for black level and white level, for instance. A set-top box probably only has a black level adjustment, if that, whereas DVD or Blu-ray players may have more complete sets of adjustments. And so the instructions here give us information to properly configure the settings in those other devices. Once we had done that, then we are basically complete, and we could view our calibration report. Let me click the Generate button in order to populate data into that. Once we do that, then we'll have a report that will be ready to either view with our customer, to print if we have a printer available, or to export that to a PDF. So we can then email that to a client, for instance. And the data will be populating here in just a moment. We oftentimes would want to use a report like this to give to an outside client, just in order to promote bragging rights for our clients, so that they can help promote us to their friends and family and relatives, so that they can show them just what a great job that we did for them. Okay, with that, let's step back to our presentation for just a few minutes. Color gamut calibration, as indicated, is something that is beyond discussion for today, an advanced topic. This would be the final step in our quality levels of improvement, kind of the icing on the cake. If we have these controls available, we would typically have 3 controls for each of the primary and secondary colors in order to be able to accurately set the saturation and the hue, and also the intensity, or the brightness level, basically, of each of the colors. So the calibration report then that we'll be able to generate gives our client tangible proof of performance, to be able to show friends and families, able to quantify bragging rights. Just a moment then, let's talk about selling our calibration services, talk about what it is we're offering, the benefits, how we should offer that to customers. We're actually offering a very full service solution tailored to our client's specific needs and viewing pleasure. We want to let our client know that we're the experts, but that we're always ready to serve them, and they're always the one that's right. We don't want to overdo the technical know-it-all, you might say. The calibration benefits are, of course, a more detailed cinema-like image by eliminating the excessive artifacts in the picture. We're going to be seeing a more detailed cinema-like image. It's going to have more lifelike, photorealistic coloration. Because of the grayscale calibration, we're going to be able to see more accurate shades of gray, and we're going to have a more dimensional image. Even if it's not a 3D picture, just a standard 2D picture will look more lifelike, more dimensional with an accurate calibration. We'll optimize the picture quality so that it's more accurately viewable in different lighting situations. We may set up one of our displays viewing modes, Expert 1, for instance, for daytime viewing, and Expert 2 for nighttime viewing, with different brightness and gamma settings, for instance, different luminance levels. We'll reproduce image fidelity to reproduce the artist's original artistic intent, so that a cinematographer or A producer or director would be able to come to our display and view their content and say, yes, that's exactly the way it's supposed to look. Also, as a side benefit, oftentimes calibration will save energy, lowering the energy draw of the display, which will also, because of the reduced heat, extend the life of the panel. You want your clients to have the best entertainment experience possible, feel good about their investment. You want to give them every opportunity to share that experience with their friends and keep coming back. One way of doing that, of course, is with the calibration report. Referrals and repeat sales are certainly great business. When you're talking to your customers about calibration, of course, you want to, in your initial conversations with them, you want to start with open-ended questions to help reveal their entertainment habits and desires. You want to make your questions easy to answer with short detail, and you want to continue with similar follow-up questions in order to lead your clients to the calibration benefits that you know that you have to offer. Some of the questions you might want to start asking are about the types of programs that they watch. What are your content sources, Blu-ray, DVD, set-top box, whatever, Apple TV. When do they watch? What times of day? Where do they sit with respect to the display? How far back? Asking them what picture qualities are important to them. So when your client is talking, you want to really be sure that you listen to them, that you get the full effect of what it is that they're trying to tell you, not interrupting them along the way, making mental notes of what they like and don't like. You want to be able to lead them to appreciate the benefits that you're going to be able to offer them, asking a follow-up question, for instance, of you said you want the TV to give you a better, more lifelike picture, right? And so you want to help them approach the answers that you're going to have to offer. In closing, then, you'll want to provide the benefit answers to each need or want that you heard them express along the way during their conversation with you. You want to ask a closing question to gain your client's acceptance, to judge their acceptance. For instance, if I were able to provide this particular benefit, would that be of value to you? To judge their acceptance. And then you want to ask for the business, actually ask for a close to the business. Would Tuesday morning or afternoon be better for a calibration appointment? To give them a choice, but to lead them toward a definite decision. In conclusion, then, you want to remember that calibrating either your clients or your own television will likely have a far greater impact on the picture quality available from that display than either the brand of the display, the features, or the technology that's used to create it. A quote from Mike Wood, but certainly true in any respect. Some other training opportunities that are available beyond this short training webinar that we had today. We do have 1-day and 2-day and 3-day training courses that are available, both directly through SpectraCal and available from the Imaging Science Foundation. These different classes are available across the country, oftentimes offered in conjunction with the major trade shows of our industry. So please check with us about that. 1-day Pro Monitor calibration training, which is an expansion upon this 90 minutes that we just had today, and a much expanded Imaging Science Foundation 3-day training are the kind of the two extremes of the offerings that are available from here. Again, check with us or check online at our website, www.spectracal.com, in order to learn about the different classes that are available. Also, you can call us to get a free 30-day trial of CalMAN that'll be activated to work either with a simulated meter if you don't already have any hardware, or activated to work with your meter and generator. So you can try it out at any time you'd like. Again, if you have questions, feel free to continue to email us at webinarsupport@spectracal.com, as you've been doing, and we've been answering some of your questions, or also call us at the numbers that are listed here anytime in the future. With that, I want to thank you again for attending this SpectraCal webinar. Hope to work with you again in the future, and have a great day.